Gravity is everywhere. Though invisible, gravity controls everything. Because of Earth's mass, the gravity on the surface of our planet is 9.807 meters per second squared. This allows us to live a healthy life that we've adapted to. It also allows us the freedom to leave Earth's gravity, which is essential for space travel. Now, imagine we shrunk Earth down to the size of a marble. Earth's gravity would become so intense that nothing would be able to escape it. And this is essentially a black hole. Black holes were first proposed in the 18th century, though they never gained much traction until 1964 with the discovery of Cygnus X1, the first black hole. Scientists had theorized about black holes dating all the way back to 1783. However, no one could accept the notion that such a powerful structure could exist in nature, a structure so powerful that light could not even escape it. Even great physicists like Albert Einstein, whose formulas helped to lay the groundwork of what we know about black holes today, stated that nature would not allow such an object to persist. Now, however, black holes play a prominent role in the scientific community. They also have pop culture reference in sci-fi movies like Interstellar and Star Trek and even Disney's Treasure Planet. But what is a black hole? We know black holes absorb all matter, and we see them portrayed in movies as dark, evil, destroying entities. However, there's so much more than that. Black holes develop when massive stars, usually at the end of their lives, collapse in on themselves. This forms massive gravitational fields that are so intense that light can't escape. This poses a problem for scientists, though. Because light can't escape from a black hole, black holes appear to the naked eye as emptiness, as just open space. So, scientists have developed a technique to locate black holes. They search for the gravitational effects of black holes on its surroundings. So a star appearing to orbit nothing could actually be orbiting a black hole. This allows scientists to locate and determine the size and distance to a black hole. The same massive amount of gravity is what scientists like Stephen Hawking theorize could be how that would make time travel possible. You see, the closer you get to the center of a black hole, the greater the gravity, and the greater the gravity, the more time slows. So for example, if you got in a spacecraft and took the shuttle to the center of a black hole, the clock would look as if time was passing normally. However, if you took this clock and compared it to one on Earth, it would appear as if the one on Earth had passed more quickly. So, theoretically, if you could have a spacecraft durable enough to withstand the journey to the event horizon, which the event horizon is essentially the point of no return of a black hole. It's the last place you can escape the black hole's gravity. So if you could take a shuttle to the event horizon, technically you could travel into the future. However, with our scientific capacity today, there is no known spacecraft that would be able to withstand this journey. Furthermore, even if you did make it, you could pass over the event horizon and be destroyed before you even realized it. And lastly, the closest known black hole would take you 2.54 million years to reach, traveling at the speed of light. However, this being said, black holes obey the laws of physics. Although they're capable of destroying planets and matter that enters them, black holes are fixed entities that cannot move freely throughout the universe, destroying planets and stars. And even if our sun, which is too small to ever become a black hole, did somehow become a black hole, our planets and our solar system would continue to orbit the black hole as if nothing had happened. And because of Earth's location, we aren't in danger of ever encountering a black hole. But the same distance to black holes is a double-edged sword, as it makes most of the research and being able to study black holes unattainable. Most of the evidence we have now about black holes is based in hypotheses and theories. Maybe one day we'll be able to discover the mysteries and true potentials of black holes. But as of now, they're too far away and too great of power for us to be able to study.